Students, our next chapter is symmetry. Our next chapter is symmetry. So, what is meant by symmetry? So, what is symmetry? So, this symmetry already we discussed in our previous classes. Symmetry means if any objects or any shapes have the same size and shape, so they are called symmetrical shapes. So, they called symmetrical shapes. So what is the basic? The basic we need. So, the basic thing we need is in the symmetry, the objects should have the same shape and size. Then we can say that they are symmetrical objects. They are symmetrical objects. They are symmetrical things. Okay. Now, here in warm up time, so do the following figures represent symmetry? Do the following figures represent symmetry? So, here two pictures are given. So, either these two pictures represent symmetry, so either they are represent symmetry or not. So, what is the basic definition for a symmetry? So, the basic definition for symmetry is, so if any shapes or any objects or anything so have the same shape and size, then we can say that they are symmetry. So, if we observe the two faces, the smiling faces, if we observe the two smiling faces, so we can say that they are symmetry. So, why they are symmetry? They have the same shape and size. They have same shape and size. So, that is why we can say that the both are symmetrical objects, symmetrical figures. So, the basic definition for symmetry is if object or any figures have the same shape or size, then we can say that they are symmetrical objects or they are symmetrical things or they are symmetrical figures. Okay. Here the given two pictures are symmetrical pictures. Why? Because they have the same shape and size, same shape and size. So, that is why the given two smiling faces are symmetrical figures. Okay, students. So, now the students see here in learning time symmetry. So, the symmetry, it is a Greek word. So, symmetry is a Greek word. So, the meaning of a symmetry is to measure together, to measure together. If two or more than two shapes are there, so then how they are, either they are same shape or size, so that measure. So, actually this symmetry is a Greek word. The meaning of a symmetry is to measure. So, in mathematically it means the shapes become exactly like together, like another. So, if two shapes are there or three shapes are there or four shapes are there, so if we compare the shapes, so how the shapes should be, the shapes should be so exactly like another. So, they are same, they look same and the same shape and size. If the shapes are same shape and size, so then they called symmetrical shapes. So, mathematically what is the definition of a symmetry? The definition of a symmetry is shapes become exactly like another. Like another means they should be same. They should be same. So, in Greek, so symmetry is a Greek word. So, the meaning is to measure. So, measure together. But mathematically, so what is the definition for this? So, symmetry, so becomes exactly like another. So, exactly like another. So, okay. So, when we move some way means either you turn or flip or slide, so how the shapes will change, so that comes under the symmetry. So, how the position of the object, how the position of the figure will change. So, either it changes into another shape or it look like the same. So, that comes under the symmetry. If we turn or if you flip or if you slide, it looks like the same. So, then the figures are called symmetrical figures. Okay. So, then actually the symmetrical shapes are same shape and size. Symmetrical figures are same shape and size. They are in same shape and size. Okay. So, see here. So, when working with a symmetry, so we are doing with a symmetrical shapes. So, the initial image, suppose if we take a or some letter, so that initial image is called pre-image. So, after that second image, whatever the second image we are forming, so that is the image. The initial image is the pre-image, then second image is the image. We call second image is a image. So then after that, so if suppose if any object is not a symmetry, so then what we can call it? So we can say that asymmetric. Asymmetric means so that is not a symmetrical, that is not a symmetrical object or symmetrical figure. So symmetrical means, symmetry means what is symmetry? So mathematically symmetry means so exactly, so looks like, so becomes exactly like another. So they should be the same shape and size mathematically, but according to the Greek meaning, so to measure together, to measure together. So this is the definition in Greek, and mathematically, so what exactly the symmetry means? So exactly like another, so means they should be same shape and size. Okay, so this is about the symmetry. And if a figure is not, if an object so is not symmetry, then what we can say? So that is asymmetric. Asymmetric means that is not a symmetrical, that objects are not symmetrical objects. Okay, here, so students, here see in the picture, so two pictures are given. In that two picture, one butterfly is given, so one pattern is given. So in the butterfly, so that butterfly is a symmetrical. So symmetrical, if we draw a line, so from the middle vertical line, if you draw a vertical line, so the two shapes left and right, so they are in same shape and size. So that is why the butterfly is a symmetrical. So symmetrical, so and the given pattern is also a symmetry. If you draw vertical line, horizontal line and slanting lines, then we can get symmetrical shapes, two symmetrical shapes, two identical shapes we can get. So these two objects are the symmetrical objects. One is a butterfly. Butterfly is a symmetrical same shape, and the pattern whatever is given in the board, on the board, so that is also a symmetrical shape. If you divide it into two parts in the from the middle, so then so it divided into two identical shapes. The two identical shapes are the symmetrical shapes. Okay, so now the students see here types of symmetry. In the types of symmetry, the first one is rotation. So to rotate an object means to turn it around. So rotation, to turn it around. So every rotation has a center and an angle. Every rotation has a center and angle. See here, so this is a circle. So if you keep here R, if you rotate at an angle of 90 degrees, so then the R will change like this. So the before rotation, then after rotation, the R will change like this. So by the experimentally, if you see here, so this is a circle, this is R. If you keep R here, if you rotate, so this at an angle of 90 degrees, so like this, if you rotate, then your R will change like this in this form. So your R will change in this form. So before rotation, your R is like this. Before rotation, the circle, this is the center. This is the center of the circle. So this is the R. If you rotate an angle of 90 degrees, if you rotate an angle of 90 degrees, then the R will change like this. This is after rotation. This is before rotation. Before rotation. So how the shape will change after rotation and before rotation. So this is about the rotation. So now translation. So translation means to translate an object to move without rotating or reflecting. Suppose here R is there. Translating means, so we have to change the position of R from one place to another. So before translating, so the R is here. After translating, we are getting R here, R here, R here, everywhere. So anywhere. So translating means, so we have to change the position of R from its original position. So to translate means without rotating, so without reflecting, so we have to change the object position. So that is the translating. So then reflecting. So reflecting. So what is reflecting? Reflecting an object means to produce a mirror image. So if you see a R in a mirror, so it's look like this. It is mirror image. So if your R is like this before, so when you see in the mirror, so the R is like this, you will see like this. This is the mirror image. This is the mirror image. Okay. Now gliding reflection. So what is gliding reflection? A gliding reflection combines reflection with the translation along the direction. here R. Translating means if you rotate here, so the gliding reflection combined reflection with the translating along the direction of a mirror line. So this is the mirror line. This is the mirror line. So when you change your position, mirror line, so then you'll get like this. Then you'll get like this in this formation. So this is the mirror line. So mirror line translation. First, whatever the position is there. So then after that you take a mirror image. Then after that you translate. So you'll get like this. Okay. Gliding reflection combines. It is combines the mirror reflection and translation reflection. So mirror reflection, after this is the original position, then take mirror reflection, then after that rotate it. So like this you will get. So this is the gliding reflection. Here we have four types of symmetries. One is the rotational symmetry, translation symmetry, and reflection and gliding reflection. So these four you should remember. So how the position, how the object shape will change. So this is the rotation means if we change in a 90 degrees, then how it will come. So then in translation so then how the object shape will come. So then in reflection, how the mirror image will form. So in gliding reflection, how the gliding reflection will form. So this all the concept you should remember. Okay. So now the students, next concept, observe the following shapes. Some shapes are given. First you observe the following shapes. Draw line of symmetry for the following. So what is meant by line of symmetry? So what is actually line of symmetry? See here, a line of symmetry divides a figure into mirror image. So when we draw a line of symmetry, so what it makes? It divides the given figure into mirror image. So and also it divides into two identical shapes. The first part and the second part both are same shape and size. They are equal in shape and size. This means they form symmetrical shapes. So that line is called symmetrical line. If a line divides a given figure into two equal halves, means divided into two equal means identical shapes, then that line is a symmetrical line. So that line we should draw. So then here a square is given. So we should draw a line. So the line should in such a way that that should be divide the given figure into two equal halves, two identical shapes. So if you draw a line say in the middle, from the middle of the square, so then it divides into two equal halves. How these two halves? These two halves are identical in shape. So this shape and this shape both are same shape and size. So this is a symmetrical line. So in such a way we think and draw a symmetrical line. Here one picture is given, so we should draw a symmetrical line. See, if I take symmetrical line like this, so then this part and this part, they are not same, they are not identical in shape. If they are not identical in shapes, the line is not a symmetrical line. Then how should we take a symmetrical line? So we should draw a line, so horizontal line we should draw. If we draw a horizontal line, so then that line divides so that given figure into identical shapes, two identical shapes, upper and lower. So the upper shape and the lower shape, the both are identical in shape. So this horizontal line, here the horizontal line is a symmetrical line. Here pentagon is given. So for this pentagon we should draw a line. So if you take a horizontal line for this, so then this horizontal line divides the given pentagon into two equal halves, two identical shapes. So this here the vertical line is a symmetrical line. So here diamond is given. So in this diamond, so this means kite shape. So if you take a horizontal line, so then this horizontal line divides this kite shape into two identical shapes. So here this vertical line is a line of symmetry. Now circle is given. So circle is having infinite line of symmetries. So wherever however you want to draw, so then you can draw. So but the line should passes through the center of the circle. So then only the line is a symmetrical line. So here this is a symmetrical line. So many infinite number of symmetrical lines we can draw from the circle. So we should think, so how to draw a symmetrical line so that the given figure is divided into two identical shapes. So in such a way we should draw. So that line is our symmetrical line. Okay students. So now in activity first, see here, so draw the other half to make the given picture symmetrical. See here, half of the picture he already has given, so other half picture we should draw to make this identical. So here see, identical picture we should make. So one more we should draw like this. So after this, so this remaining half you should draw, okay, so that it makes identical shapes. It makes identical shapes, okay. The next here also remaining half we should make so that it makes identical shapes. So it makes identical, so that it makes identical. Okay. So here also we should draw a picture so that it makes identical. We draw a cylinder, okay. So in this way we should draw the remaining half of the picture, okay, so that it makes identical. So after that more three questions given. So one is butterfly is given, so half of the butterfly he has given, so remaining half butterfly you should draw and make it asymmetry, okay. It's remaining, so like a plane shape is given, so using a straight lines you draw half of a remaining plane. And so other one, the sixth one is milk bottle is given, half of the milk bottle is given, other milk bottle you should draw. So remaining three questions you do as your home assignment, okay students. So now our next concept, visualizing the symmetrical figures. Visualizing symmetrical figures. Here, so 4 historical monuments are given. So 1, 2, 3, 4 in that picture. So what is given? 4 historical monuments are given. So then in this, so the second one is a Taj Mahal. So in these 4 historical monuments, so how these monuments are? So all these 4 monuments are symmetrical in shape. How we know that all these 4 are symmetrical in shape? So if we visualize, means if we observe carefully all these 4 monuments, so these are symmetrical. How these are symmetrical? If we draw a vertical line, so then the left and right, both the parts are identical. Both the parts are identical. So if you draw a vertical line, so then how the shapes, the left and the right, both the shapes you will get the identical shapes. So when if we draw a symmetrical line, so that divides into 2 identical shapes, then that shape is a symmetrical shape. So this we discussed previous. Here these 4 historical monuments, if we draw 4 vertical lines, so like 4 vertical lines, the left side and the right side, left side and right side, left side and right side, left and right both the sides, so will form identical. So identical shapes we will get when if we draw a vertical line. If we draw a vertical line for this all 4 historical monuments, then you will get identical shapes. Once we are getting identical shapes, that means they are symmetrical in shapes. So no doubt symmetrical shapes are very beautiful shapes. So that is why all these 4 are very beautiful in shape. So whenever the monuments or whatever the buildings and so constructions, so if they are symmetrical in shape, so then they looks very beautiful. So they looks very beautiful. So that is why here, so all these 4 monuments, so what we are seeing, so in this picture, so all these are, so looks very beautiful, because all these 4 shapes are 4 building structures are, monument structures are symmetrical. How these all 4 are symmetrical? So because if we draw a vertical line, so for all these 4, so then we will get 2 identical shapes, left and right. So that is why these 4 are identical in shapes, so they are symmetric. Okay students, okay.